Now, if you look at Equilibria, yesterday I have actually introduced to you related to Equilibria. So what I want you to do now, I want you to discuss, for 2 minutes, on activity 1. Activity 1 is over there. Do remember, one of the, it's a group submission. One of the submission when you write, you need to take picture and you need to actually put it in the Padlet link, So please take note. Let's actually begin now. Discuss. This is not with shoulder partner, discuss as a group. Yeah, discuss. What's the difference between the two equations? Yeah, so just tell one has forward and reverse reaction. Another one will go into completion. Yeah. So what is the one that you're going to write? Reversible. Okay. So or you can say one will reach equilibrium, another one will go into completion. Yeah. You can add on to that. So what's the discussion? What are you guys going to write? Okay. Backward reaction. Anything else you can add? One will reach equilibrium, another one? Reversible will reach equilibrium. Another one will go into completion. The one that only one arrow will go into completion. I hope you heard what I said to the other group. So one is reversible. Another one is not. So the reversible has forward and backward reaction. So it means that one can actually reach equilibrium. Another one will go into completion. So one person put all this together, take picture, put it in the Padlet there. So the idea is one is reversible, another one is not. So the reversible will reach equilibrium, another one will go into completion. Yes, it will finish off. So all the calcium carbonate will completely decompose. Okay, take your time now. The time is up. Take your time now to take picture. Only one group, One group take picture, put that picture in the Padlet link. Done? Hurry up. So I think I'm going to assign one person here. The person who are sitting over here. One person. Will become the leader to upload everything into the Padlet. Up to you. We have to go on. We are already late. Now, you see here, when I mentioned about reversible reaction is going to be a reaction where they are going to reach equilibrium. So equilibrium, generally they are going to have 4 criteria or characteristics, which is going to be number 1 is dynamic. Dynamic means they are continuously reacting even though they reach equilibrium. The reaction never stops. Then the rate of forward and reverse reaction are going to be the same. So there is no such thing that there will be more product is going to be formed and so on. It's going to be continuous. The rate of formation of product, the change from product to become reactant is going to be the same. The concentration in the reversible reaction, they are going to remain constant. Constant is not mean the same. They are going to be not changing. They are not changing. And it requires a closed system. Now, in the activity number 1, can you identify which is the one that is not in the closed system? Kathleen? The second one, the one that goes into completion. Do remember, even though calcium carbonate, okay, is a reversible reaction, okay, but okay, because okay, you are removing the carbon dioxide, okay, open system means they are reactant or the product can escape. Yeah. So once they escape, okay, there is no carbon dioxide, so there is no conversion or there is no reverse reaction. Okay, therefore, okay, it just follow forward reaction. Okay, now what I want you guys to do now is to discuss and complete activity 2. Okay, start. Okay, hurry up, we don't have a lot of time. Yeah. Okay, activity 2. This is also included in activity 2. Yeah, the graph. Dynamic, okay, forward, same, yeah, okay, requires closed system, no problem. Now you actually figure out about the graph. At the beginning, there's hi, correct? So you put the x at here. Maybe at the beginning there is hi. Over time, there is a decrease. Okay, they are going to decrease. And there is going to be at equilibrium. This is going to be at equilibrium. So they are going to decrease from here to here, maybe. Yeah. Yeah, you have to put x. No need to put 2. Okay, let's figure out on the graph. Yeah, so you just put x over there. It will decrease from here to there, right? So you draw the curve, and then another one will increase. But the increase and decrease, are they going to be the same? Half. Okay, it will follow the number of moles. Okay. Yeah, correct. Anderson is correct. Yeah. It will be decreased from here to here, and then this one H2 or I2 will increase maybe half of it. Okay, draw. Now the time is up. Yeah. So whatever there is a decrease from here to here, it will become half. Yeah, 2 to 1. So it will be like half of that. So small amount. So they will increase from 0, because at the beginning there is no H2. Okay, at the beginning, okay, there is no H2, so you need to include the H2. Okay, the graph, hurry up. Okay, the graph. Okay, good already. Start, one person take picture, okay, and upload. Okay, start uploading, should be okay. Then after that, straight. Straight. Yes, you label. Now, after the equilibrium line, draw a straight line. Yeah? Yes. Correct. Correct. No, I2. This one, the one decreasing is HI. And then I think the increase should be, if you are decreasing this much, the increase should be half of it, right? 2 to 1. The one over there is correct. Anderson's one. Yeah, this is wrong. Yeah? If there is a decrease over here, HI, then half of it, okay, 2 to 1. So the increase will be maybe up to here only. Yeah, please check each other's. This one was straight, yeah? Don't have ruler, yeah? My son put it in my bag. You can put, yes. All right, guys. Okay, is it done? Already put in your Padlet? Okay, I think just take picture and put, yeah. So whoever done, okay, you just put. Now, okay, guys. Okay, we need to continue, yeah. So please look over here. Now this is new. Okay, this is new. So please take note. Now we are going to look into this equilibrium constant. Now what is equilibrium constant? If you have any equation, okay, you can see the equation over there. Now when we are writing the expression for equilibrium constant, the expression for the equilibrium constant is always product divided by reactant. Please remember that. And the power, okay, and the power will be reflected by the number of moles in front, the stoichiometric reaction, yeah. So if you have, let's say, for example, I give you, okay, let's say SO2 plus O2 to give me SO3. Okay, this is my reaction. Okay, and then I am going to actually write the Kc. Kc means equilibrium constant. C means concentration. Concentration is number of moles divided by volume. Yeah, volume is in dm cube. Now, Kc expression is product divided by reactant. Please take note. Product concentration of SO3 to the power of 2 because of these two, divided by concentration of SO2 to the power of 2 times concentration of O2. Quite simple. And if you want to find out the units, the unit is mole dm negative 3 to the power of 2 divided by mole dm negative 3 to the power of 2 mole dm negative 3. You can cancel this. Okay, and then you will have 1 over this. So bring it up, mole negative 1 dm 3. Every expression, okay, will have different units. Okay, now if you look further, okay, if I want to write the expression of that, you see I have shown you, okay, with the unit. Okay, it may be small, okay, but you can see over there. But if you look at the another equation, okay, another equation is given over there, although it's quite small, okay, but okay, if you look over there, is Ag plus aqueous plus Fe2 plus aqueous Ag solid plus Fe3 plus aqueous. Now, when I write down the Kc expression over here, it's supposed to be this concentration times this concentration divided by this concentration and this concentration. But if you look over there, something is missing. Can you identify which one is missing? Haruto? This one is missing, right? Okay. Why it is missing? Because solid is not counted in. Why solid is not counted in? Because solid, the concentration is always constant. Okay, we do not, okay, put the constant concentration over there. Okay, so do remember, okay, the important point to remember over here for Kc, okay, if you are dealing with aqueous solution and so on, even for gas, you can use Kc, but do remember solid will not be there because concentration is constant. Okay, now let's carry on. This is, since I brought in gas, okay, for gas is slightly different. In order to learn about gas, you need to know about partial pressure. Now, what is partial pressure? Let's say the entire pressure, okay, in this particular room, let's say is going to be 100 Pascal. And let's say we have two types of gases over here. Let's say hydrogen and oxygen, two types of gas. And hydrogen and oxygen, we have maybe 0.1 mole of hydrogen, and we may have 0.4 moles of oxygen. And there are only two types of gas over here. Now, what can you find out from here is, we can find out what is going to be the mole fraction. What is mole fraction? Total number of moles, which is going to be 0.1 plus 0.4, which is 0.5. Mole fraction for H2 is 0.1 divided by 0.5. Mole fraction of oxygen is going to be 0.4 divided by 0.5. From this mole fraction, okay, you can calculate the partial pressure, because all of them going to contribute 100 Pascal. So what is the partial pressure? I use P, yeah? Partial pressure of hydrogen is the mole fraction, okay? 0.1 divided by 0.5 is 1 over 5 times the total pressure, okay, which is 20 Pascal. It means 20 Pascal is contributed by this, and the remaining should be 80 Pascal, but you can calculate. Okay, the partial pressure of O2 is 4 out of 5 times 100 Pascal. That's going to be 80 Pascal. So basically, I am going to calculate each gas is going to contribute how much pressure. And using that, we are going to express what we call as equilibrium constant, but for gas, we call it Kp. Okay, Kp means we are using the pressure, partial pressure of the gas. Okay, so let's say, okay, I want to write down the Kp for this reaction. Okay, it's gas. In order to use Kp, we must focus on gas. Okay, all of them are gas. And if I want to use Kp, similar, okay, but you just need to change partial pressure, P, SO3, 2 to the power of 2. Similar, concentration to the power of 2. Okay, divided by partial pressure of SO2 to the power of 2 times partial pressure of oxygen to the power of 1. Okay, and once you have the partial pressure, you calculate, you put them in, and you just do your simple calculation. Quite simple. Okay, just put in the value. And the unit calculation is similar. Okay, you can have a look at the example given. You can actually calculate the unit. Okay, Pascal. Okay, pressure, the unit is Pascal. Okay, now I want you guys to start with activity 3, but for this activity 3 is longer, yeah, for 5 minutes. Okay, and I will help you out over here. Discuss. Okay, discuss. For how do you write Kc? Okay, hi sir. So how do you write for Kc? Oh, so you already calculated, yeah? So you need to discuss. So first, okay, they ask you Kc expression, yeah? So you calculated the unit straight away. So Kc expression, you need to write like what I've written over there, the SO3. Can you see that? Kc equals to SO3 bracket then 2. That is expression. Yeah? So guys, okay, please take note. When they say write the Kc expression or Kp expression, this one. Okay, you need to write this. Kc, all right, okay. Why liter? Mole per dm cube. We don't use liter, yeah? Concentration, okay, concentration is always number of moles divided by volume. Mole dm negative 3, okay? That's the unit. So you just need to calculate the concentration. Okay. 2 and 4, you cancel. To the power of 2, to the power of 4. So to the power of negative 2, right? Check your conversion of units, yeah? Negative 2, yeah? So you bring it in, mole negative 2, dm to the power of 4. Negative 2 times, this is 3 or 2? This is 1, this is 3, 4, right? 2 divided by 4 is negative 2, right? Mole, you cancel. Why 2 and 3 you cancel? Oh, yeah, this is correct. Correct. Yeah. Use your indexes, yeah, properly. Okay. So even though you cancel the units, okay, make sure the units are calculated properly. Okay, those who are still confused, please have a look over here. So this is mole dm negative 3 to the power of 2, mole dm negative 3, 3 and 1, so it will be 4, 4, 2, okay, it's going to be mole dm negative 3, 2 minus 4, or you want to cancel also, 2, and then cancel with 2, 2 go up, negative 2. So it will become negative 2, bring it in, mole negative 2 dm positive 6. That's the unit. Anyways, okay, times is almost up. Hurry up. There should be, you should be working on this partial pressure. Yeah. Pascal. But you must actually cancel similarly like just now. Pascal to the power of 2, Pascal to the power of 4. So it will become Pascal to the power of negative 2. Once you're done, you check with your group, okay? Come to an agreement and then take picture and put it in the Padlet link that I given you. Can I see? Carefully. Okay, Pascal negative 2, correct. Important to work on this partial pressure, yeah? Partial pressure, you see, yeah? There are 3 types of gases. So total is, you add is 1, right? Now, so if you want to find the partial pressure of nitrogen, so 0.1 divided by 1 times total pressure, 10. Okay, then you do the same. 0.2 divided by 1, no, total. You look at the total. Find the mole fraction just now, yeah? I add these two, right? So find the total. Whatever that you are calculating, you divide times with the total pressure. And you will get the partial pressure only. Then you have to put them in. Add the number of moles, 0.1 plus 0.2, 0.7. So you get 1. Can Alden? Yeah, this one, 0.1 times 10 is 1. 1, 2, 7. So now that is the partial pressure. So write the expression, put the value in. Yes. Okay, this group already take picture and put in the Padlet. Okay, this is correct already. How about this one already? Put in Padlet, yeah? Okay, you guys are already working on activity 4. Okay. Now, I see some of you already working on activity 4. Now, for activity 4, before you start working on that, okay, we need to revise again about this Le Chatelier's principle, yeah? Okay. So, make sure, yeah, the group leader take note. If you have not submitted, then you have to still submit. Now, let's everyone stop for a while and look over here, yeah? Now, we are going to explore again about the principle, yeah, the Le Chatelier's principle. Now, this Le Chatelier's principle tells that, okay, whenever, okay, when a system is in equilibrium, when you make changes to it, the position of the equilibrium will change so that it will minimize the change or to remove the change. Okay, and we have already learned about that yesterday. Now, if you put over here, okay, of course, if it is too small to read, I'll just put ethanoic acid plus ethanol, ethyl ethanoate, and water. Now, the thing over here is, the question is asking what happens, okay, when you add more ethanol. When you add more ethanol, according to Le Chatelier's principle, you need to remove the ethanol. How do you remove the ethanol, Rico? Shifting it to here, to the right, yeah? So basically, you are making ethanol to react more, okay, with this ethanoic acid. Okay, so you are going to get more of this, more of that, yeah? So how you explain, I already explained to you how to explain it, yeah, when in exam. Okay, and then what happens when we add more water? Okay, let's look at it. When you add more water, concentration of water is increased now. So, Felicia, okay, water is increased. You need to remove the water. How do you remove the water? Moving to the left. Yeah, you make sure water react with this. Okay, and then what happens if you remove the water? Okay, it means you are decreasing the concentration of water. So you need to increase the water. Okay, so Russell, how do you increase the amount of water? Forming more water. Yeah, so you need to go that side. Now, this one shouldn't be any problem. Okay, but if you look over here, okay, there are 4 factors that we need to study. Okay, and we have studied about concentration. Now, I have also explained to you related to catalyst. Okay, so catalyst. Okay, let's actually hear from Nicholas. Yeah, Nicholas, for catalyst, I already put over there. There is no effect towards the position of the equilibria. Yeah, can you explain why? It's too little to see, but I think can you explain why catalysts don't have any effect? What is the function of catalyst? Okay. Okay, increased rate of reaction. Good. But for reversible reaction, it's going to be slightly different. It increases forward reaction rate or backward reaction rate. Both. Good. So we know equilibrium, both rates are going to be the same. So if you increase both, nothing will happen to the position of the equilibrium. So that is how you explain. Okay, but now I'm just going to show you for the temperature and pressure. Now for the temperature and pressure, I'll show you for pressure first. Now for pressure, if you have SO2 plus O2, okay, to give you 2 SO3, all of them are gas. Okay, do remember for pressure, the pressure change only affects those in gas. Okay, now let's say for example, this system is already at equilibrium, and I am going to make changes to this equilibrium, which is I increase the pressure. Now before we do that, okay, the first thing that we need to do is to do some mathematical calculation. Look at the number of moles, okay, over there. And if you look at the number of moles over there, okay, I forgot to put 2. If you put the number of moles over there, 2 plus 1, okay, that's going to be 3. You put the 3 there. And you put the 2 there. And always remember, in a room, if you have many people or many molecules, you will have more pressure because the molecules will hit the wall of the container more. Okay, it means more molecules, more pressure, less molecules, less pressure. If I have higher pressure, according to Le Chatelier's principle, they need to decrease the pressure. How do you decrease the pressure? Mayumi, how do you decrease pressure? By forming less molecules or forming more molecules? Less molecules. So it will go from 3 to 2. Bigger number to smaller number. Okay, so the position of the equilibrium will be shifted. Don't say shifted to number 2, will be shifted towards less number of molecules. Okay, so it will go there, making more SO3, less SO2 and O2. It will be shifted a bit. Okay, now what happens if we have a situation where I have H2 plus I2, 2HI, and all of them are gas? 1 plus 1, 2, 2. If I go and decrease the pressure, what will happen? No change. Good. Why? The number of moles are the same. So nothing will happen. If you increase pressure or decrease pressure, nothing will happen. Okay, that is going to be a little bit about pressure. Now, do remember when you explain about pressure, I want you to remember, explain about the position of the equilibrium, explain about whether it moves to less molecules or more number of molecules. I think that's the guide. Now, let's actually look at this effect of temperature. I will use the same example. In order to look at effect of temperature, you need to know what is the enthalpy heat of reaction. And this, for this reaction, is an exothermic reaction. Okay, why exothermic? Is a combustion. Okay, combustion, all combustion must be exothermic. Okay, now this is exothermic. Remember last time I told you to remember when something is endothermic or exothermic. If you have a beaker, you put your hand. Now you put your hand here. Okay, and it is exothermic. So Nicholas, is it going to be hot or going to be cold? If it is exothermic, hot. You put hot over there. And you put another hand here. If that is hot, this is going to be cold. Okay? Now, let's say I'm going to make changes now. Temperature, I'm going to increase the temperature. I'm going to disturb the equilibrium. According to Le Chatelier's principle, you need to decrease the temperature. How do you decrease the temperature? Hot to cold or cold to hot? Yes. So, it will go here. But when you answer, don't answer it will go to the left. You answer the position of the equilibrium will be shifted. Forward is exothermic. It is going backwards. You explain the position of the equilibrium will favor endothermic reaction. Okay, favor endothermic reaction. And it will result in forming more of these two. Okay, and vice versa. Yeah. So explanation, you explain about the position, explain whether it is going to favor endothermic or exothermic. Okay, now do remember one thing. We come back again to Kp and Kc, equilibrium constant. From the term constant, constant means it's always going to be the same. But do remember, equilibrium constant is constant for concentration, constant for pressure, constant for whenever you add catalyst, but whenever you are talking about temperature, it's not constant anymore. Okay, Kc and Kp is affected, they are affected by temperature. Okay, and if you look at the question over there, they ask, okay, deduce the effect of increase in temperature for the value of Kc. Now, let's say for example, even we don't look at that example here. Let's say I'm just going to look at this value. And I'm going to look at Kc. Kc is SO3 to the power of 2, SO2 to the power of 2, O2. And, okay, this is the expression. And I am going to increase my temperature. Let's say, for example, when I increase the temperature for this reaction, okay, just now I told you, this is negative, this is hot, this is cold. Increase temperature, I need to decrease the temperature. So I will go from here to here. It means that SO3 is decreasing. You are forming more SO2 and O2. If you replace with numbers, yeah, this number is getting smaller, divided bigger numbers, what do you expect the Kc will be? It will become smaller, okay? Kc value will decrease, okay? So you can expect from here. But if you look at that explanation B, they say why increasing concentration do not have any value or effect towards Kc. Now, if you do any kind of changes to the concentration, what happens, okay, if suddenly I increase the concentration of SO3, what happens? This concentration must be decreased, so therefore I go backward. Now, in that process, what happens? SO3, okay, will decrease, okay, but this one is going to be formed more. But earlier I increase, okay, there is going to be some sort of change. You cannot actually match to the original condition, okay, and there will be some kind of changes that will happen. They will rearrange the position until the Kc is going to remain constant, okay, so it will rearrange. But for just now, there is no opportunity for them to rearrange to get the same ratio. Okay, when there is going to be changes in temperature, the value confirm. Okay, the confirmed value, okay, the reactor, the product is going to be increasing. Reactant is decreasing. So confirm the value will decrease. But this one, there will be some kind of changes will be done. So basically the point is the same ratio will be achieved. Yeah. So the important thing over here is Kc value and Kp value, yeah, they are not affected by other factors except for temperature. And we need to look at the reaction first. And we can say whether Kc will increase or not. Yeah. Now, for this activity, you have 10 minutes. Yeah. Discuss and complete activity 4. I think since some of you already started, yeah, we will actually use less than 10 minutes, yeah.
And then increase temperature for effect of what? For effect the Kc or Kp increase for temperature. But everything else unaffected, yeah. And the temperature shifting left and everything shifting right.
Okay, correct.
Yeah.
Okay, good. Here?
So this one, if you increase the concentration, it will shift.
To the right.
But how do you like put it in first?
Which one?
This one, how do you like explain that?
You just say shifted to the right for now. Yeah, just shifted to the right. But in the actual paper, yeah, you just say shifted to form more ammonia. Is it okay? Do remember for temperature, you need to consider the enthalpy change of reaction. Yeah. Addition of catalyst, rate increases both. Yeah. So position of the catalyst, no effect. Okay, no effect. Increase temperature, this is hot. You need to actually make from hot to cold, so it will go backwards. Temperature increase, yes, rate will increase. Favors endothermic, correct. Kc and Kp, it is going backwards. So this one is going to be smaller, product is smaller, divided by bigger number. Okay, decrease, correct. Pressure, generally more pressure, rate will increase. Okay, position of the equilibrium, 4 to 2. When you increase pressure, less pressure, so they will go to the right. Okay, and then
Favors exothermic or both?
no, you just say to form more ammonia. Okay, for the temperature only you say endothermic or exothermic. Okay, here. It's okay for now. You say shift to the right or left. So what's the constant over here? Increase temperature, whether it's decreased or not. Yeah, hot, cold. Okay, so you increase temperature, it will go to the cold, so it will go behind. So this value will become smaller, divided bigger number, so decrease, correct. Yeah, all these are correct. All increase. Okay, if you have done, take the picture, okay, and then upload in your Padlet. Okay, I do see some of you already moved to the next activity. Yeah. Now, before you go to the next activity, just look over here. I'm not going to write it down. Okay, you see, basically all the details are given, and you just need to put the value in. Okay, for this example, concentration means number of moles divided by volume. Okay. Do remember in this example that I show over here, they forget or they didn't show the volume. It means all of them, okay, 0.364 and so on, must be divided by 0.5. You see 500 cm cube. Okay, it must be 0.5 dm cube. And eventually all these 0.5 dm cube, they will cancel. Okay, but not all situation the 0.5 dm cube will be cancelled. Okay, so you just take note of that. Okay, so when you replace that, okay, do remember concentration is number of moles divided by volume. So we need to consider the volume. Okay, don't miss out that. Okay, but now, okay, this is not so interesting. Okay, you try calculation 2, yeah, which is going to be your activity 5. Okay, so this one no need to upload in your Padlet, yeah, you just try. If you have done that, you can continue with activity 6 as well. Okay, just need to find the partial pressure, put it inside the equation. Increase pressure, yeah. So 1 plus 3, 4, and 2. Increase pressure, you need to decrease the pressure. So from 4 to become 2. You go to smaller number, so they will form ammonia. Yeah. Take the whole pass, yeah. Now, for this question, read the question properly, yeah? Okay, guys, just have a look over here. Maybe this will help you in solving this question. Now, I always use one of the popular method to solve this is by using this term ICE. ICE stands for initial, change, and at equilibrium. Now, initially, you were given this amount of moles, and you should know initially there's no product. And they say at equilibrium, the product is this. So there is a change of, from 0 to become this, there is a change of plus 0.0233. This is very important. Why? You look at the number of moles, 1, 1, 1. Okay, it means every change, okay, is going to follow the same number of moles. But these are reactants. Reactants must be, if 1 mole increase, there should be 1 mole decrease as well. The change must follow the stoichiometric equation. So if this is plus this much, this will be minus the same. This should be also minus the same. What you need to do is to find this value. How do you find this value at equilibrium? 0.05 minus this value, you will get this value. This minus this, you will get this value. Once you get the value, okay, calculate the Kc by using all these values. Do remember it's number of moles only. Check also what is going to be the volume. The volume in this case, I'm going to assume 1 dm cube because everything is mole per dm cube. Okay, so I'm going to assume everything is in 1 dm cube. Any issue? Yeah. Earlier, it's already given. Yeah, earlier it's already given. So the change, this value, I get it because of this. They say at equilibrium, this is the value. So I get this plus. From there only I get these values. Then you just need to initial minus the plus the change. Yes. So what will happen at equilibrium? 0 plus this, then you get this. This minus this, then at equilibrium you can calculate. 0.05 minus this value, you can calculate for the equilibrium. Okay, I see some of you getting the answer already. $32.7, yeah. Unit, how about the unit? What is the answer? What? You just calculate, you just follow up from there?
Why is it minus on the reactant?
You see, reactant and product. Okay, in order to get reactant will react. Product gain. So product, that's why product is plus. Reactant will react. During equilibrium, when you have reactant, no product, reactant will react to give you product, and reactant will decrease, right? So the change is minus over there.
Then wait, why initial?
Initial is already given. At the beginning, they only have these two reactants. There is no product. Then they react only will give you the product. Do remember, equilibrium is not achieved immediately. They will take time. If you have done, okay, no need to upload in Padlet. You just move on to activity 6. Activity 6 is quite simple actually. Sorry. If you don't have time for activity 6, you can do it at home. Yeah, this one, activity 6 is quite simple. Yeah, not like this activity. You just need to substitute the value. Activity 5, the answer, yeah. I'll just write down. Okay, guys. So now, you can continue the calculation later, yeah? I think some of you are doing activity 6 already. Now, guys, everyone listen up over here. Now, the next thing that I want you guys to do is, okay, is this one, okay? Now, each of you now, I want you to think 3 important things that you study today, and I want you to think of 1 important thing that you think still have problem that you need to still revise. Think now, okay, individually. I cannot give you 2 minutes, okay, it will be less than that. Start to think, or maybe write it down. No, now think first, okay, don't write it down in the Padlet, think first. 3 important things that you have learned today, and 1 important thing that you think that you need to still study at home. Okay, or maybe we need to practice more. Now, remember I told you, okay, I want you to pair up with your shoulder partners, yeah? I want you guys, okay, to share. Okay, share and come up with common agreement. Okay, what are the important things, okay, that you learned today, and what are the things that you need to improve? Share. Okay. I can see you guys discussing about it, yeah, but we don't have time. Yeah, actually, I wanted you guys to do something. Okay, this one you can do some other time. Okay, I want you to do a group reflection video whenever you're free, during break time, okay, and so on. Get your groups, okay, to reflect together. Just make a short video and put it inside our Padlet. Yeah, the video can be 30 seconds also. Okay, just say we learn this. We are going to do this. Okay, and this will be actually graded as well. Can you do it by today? Yeah. Okay, with that, okay, thank you guys. Okay, thank you everyone. Okay, before you guys leave also, I'll give you the follow-up activity as well. There's past year paper questions as well on this chapter. Yeah, thank you, Mr. Samuel. Bye, thank you, class. Okay.